It turns out that near the equator, there's something really amazing going on. That's a region of hot water and hot air. And the dynamics of that area dominate what happens in the weather worldwide. So we're going to learn a lot about that. But we'll take it just a little bit at a time. Let's take a look near the equator at what's going on.
There's a hot and wet region on the Earth, and I'll bet you can guess where. Near the equator is where the most intense portion of the sun's heating is taking place. And as you will soon see, there typically is a lot of rain there. It is striking that this band of rain can easily be seen from space. Here's the average annual precipitation across the Pacific. There is definitely a pattern here. Let's take a look at it. It's called the Intertropical Convergence Zone, or ITCZ, and we'll study its many interesting features over time. But at this point, we are going to only study the simple physics of hot-wet air, and it will quickly become obvious that what happens in the ITCZ won't stay in the ITCZ. It will spread out and form the weather of the world. So, there's only a few things to get straight. Hot air, like we have near the equator from the sun shining down, can hold a lot of moisture, which we also have plenty of near the equator. Hot air expands so it gets less dense and wants to rise up from the surface. But it's cold up there. There's a reason there's snow up on top of mountains. When the wet hot air gets cold, the water vapor in it condenses out, and we see that happening because clouds start forming. The air no longer can hold the water, so clouds form and it rains. Interestingly, and we'll look into this another time, after the rain is squeezed from the rising air, that air continues to rise. Its fate will be a major driver of weather worldwide. But as I said, that's another story. So what's our nugget? Remember, everything we look at is real. That line of thunderstorm clouds roughly along the equator is really there a lot of the time, and certainly dominates the average picture over a year. The physics which causes that line of clouds is simple and critical to understand. It is this: the sun heats that area intensely. This forms moist and hot air. This air surges upwards into much colder air. The cold squeezes the water out and heavy rains result. We'll track the leftover, now cold and dry air another time. It is profound what it does to global weather.
I studied climate science for years before I even heard of the ITCZ, and yet it's a big deal. We're going to learn about it over time, in little chunks at a time, but it's important. It drives the weather around the world, and it's a good nugget to chew on. Take care.